Hi everybody, this is your instructor for the CSC 2144 Programming 2 with C++. I am making this video for chapter 11, which is provided under the module section. As we go down, you can see that for every week we cover one chapter. For chapter 8, we are doing it in week 4 and week 5, where you have to do the quiz and assignment. Similarly, as you go down, you can see for chapter 9, chapter 10, and from week 10 and week 11 on weeks, you'll be doing chapter 11. And similar to how I have done in the previous weeks, making this video lecture and assignment help for you, so you can use this to do the quiz and the assignment for the chapter covered in that week. I'm doing this for chapter 11, and I should be posting the assignment aid video lecture and the assignment help right here under week 10 and week 11. So without any delay, let's go to chapter 11. Chapter 11 is about inheritance and composition. This is an important chapter which is in line with the last chapter, which was chapter 10 about the classes and data abstraction. So it's really in line with what you have learned in the previous chapter. We'll be covering about inheritance, which is one of the very important aspect in object-oriented programming. We'll be learning about derived and base classes, explore how to redefine the member functions of a base class, examine how the constructors of the base and derived classes work, which is very important from C++ syntax point of view. Learn how the deconstructors of a base and derived classes work. These are some conceptual points that you will be learning. Learn how to construct the header file of a derived class. Again, this is from a syntax point of view very important, as you will be seeing in the lecture today. Become aware of the stream class hierarchy. Just understand how things have implemented by the creators of C++ in line with the topics of this chapter, inheritance and composition. Explore three types of inheritance, which are public, protected, and private. You may have come across public and private in our prior lectures. Protected will be covered in this chapter, as we'll see shortly. We'll also learn about composition, which is called aggregation, how we can use it along with inheritance to solve complex problems. And we'll become familiar with the three basic principles of object-oriented programming. So these are the topics we'll be covering in this chapter. As you can see, from last chapter, we learned about abstract data type, which was in chapter 10. And abstract data type is not something that we declare in C++. It's a concept. And how do we implement the abstract data type? By using classes and objects. Okay. It's what's an object? It's a representation of a class. What's a class? A noun. We need to think of a noun. A noun has a person, place, or thing. When you're thinking about a class, it has two parameters. What are the elements of that, and what are the actions that can be done on that class? So that's what we learned in last chapter. The concept in this chapter, particularly inheritance, comes from the fact that when you have when you have to implement relationship between related classes, you use this concept of inheritance, such as, hypothetically speaking, or just, in general, we are all humans. So we all derive from a class called human. And then we are the objects. Now, if you have to implement like employee, the employee is obviously a human, but employee has certain characteristics which are above and beyond the characteristics of a human. What does a human have? Just imagine, for us living in America, we will have first name, last name, middle name, date of birth, SSN number. These are common for everybody living in America. But what about an employee? Well, the employee class will also have a name, first name, last name, middle name, date of birth, SSN number, but he or she will also have the employer name, the start date of the job and things like that. Now, what about let's just say student? Every human, for example, has first name, last name, middle name, SSN number, date of birth. But if somebody is a student, he not only has the information about human, but also has information about what college he is going, or what courses she is taking, and other aspects, the student ID number. So those are the things that comes in when you are talking about inheritance. Okay. In this example below, you can think about like a employee class and a part-time employee class. So part-time employee class basically is going to be a derived class, a class that comes from employee class or another class which would serve as a purpose of a parent class. Okay, so when you have to think about inheritance, always think about what is the parent class that will be used in my situation here. So if you are having a class called person type, basically every individual is a person, for example, and then we have a part-time employee. So part-time employee will have the information which are common to the person type, but will also have some information very particularly about the part-time employee. Okay, let's say we have a clock. We have a clock type, which is basically a generic clock. It has the ability to capture hours, minutes, and seconds. What about we create a class called extension clock type to accommodate new information that we want to capture, such as the time zone. We can derive the uh, extension clock type from the clock type because it still needs to have the information such as the hour, minutes, and seconds, but it will also have information about time zone. So that is what we are calling as a derived class. A subclass as well can be used pretty easily. How do we depict the inheritance in a UML diagram? Here we have a class called shape, and circle is a derived class. We have a rectangle, which is a derived class from shape, and square is a derived class from rectangle. So it has a parent and a grandparent. Okay, you can have classes where it derives information from just one class. In this case, it will be single inheritance. When derived class, when a subclass is derived from more than one, then we call it multiple inheritance. So the derived class is derived from a single base unit. In multiple inheritance, the derived class is derived from more than one base classes. In this chapter, we'll be covering only about the single inheritance, just to keep the discussion simple. Okay, what's the syntax for creating a derived class or a subclass? You will say class, the class name, which would be, let's just say um, part-time employee. Then you will have member access specifier, which could be public, private, protected. We'll learn about what does it do, and the base class name, which would be person type. And then you will list all the information about what are the different elements, the functions and the methods and the attributes. So this is how you will be declaring what's different here: the semicolon, the member access specifier, and the base class name. So let's take a closer look at it. So you have, a class called shape, and you're saying circle is derived from the shape class. So you will say class circle public shape. You can also say class circle colon private shape. What's the difference between this? We'll learn about it. But if you don't use any of the member access specifier, you don't write anything here, you just write like this, then it is similar to basically using private specifically or explicitly. Okay, so what happens when you are using the private? The private members of a base class will remain the private to the base class. The members of the derived class cannot directly access them. In other words, when you write the definition of the member functions of the derived class, even though the private member of the base class are derived in the derived class cannot directly access them. The public member of a base class are inherited either as public or protected public members or as private members by the derived class. So as we continue to go through this discussion, you will see how this member access specifier can actually have quite a drastic impact. So if we use public, whatever members are there in the shape are available to our subclass, our circle class. If you use private, then all those public members will become private. So the circle class cannot directly access any of the attributes or any of the functions that are declared as public, because by using the private, we made all of them private to the child class. We do that for certain reasons, which we will learn shortly. The derived class can include additional members, data, and/or functions. We'll learn that shortly. The derived class can redefine the public member functions of the base class. That means if you have a shape class and you have a function called print, well, in the circle, which is a derived class, you can create another function with exactly same name called print, and change the behavior entirely. This is one of the very important things in object-oriented programming. All member variables of the base class are also member variables of the derived class, unless we are using that private, okay? Even if we are using private, we can't access them directly, but if there are functions created to access them, then they are still available to the derived class. Okay? Redefining or overriding member functions of the base class, just like what I was talking to you about, where you have a class called shape, which has a function called print. You can redefine that in your circle class definition entirely, which is exactly what they are talking here. Now, what if you have a base class such as shape with a function called print, and you have a subclass or a derived class with a function called print? How do you which one will be hard? Well, there is a way to whether we want the print from the shape class to be executed or we want the print function from the circle class to be executed in this example that we are continuing. So let's say we have a rectangle type, which is a class, it has some public function, set dimension. A rectangle has a length and a width. Then we have a get length class. These are all public. We have a area class. We have perimeter class. Cleaning. And then we have another constructor which takes length and width and sets the two private member variables, the length and width. How do we display this in a UML diagram? This is how it will be displayed. Here are the few attributes, and here are the functions present in the rectangle type. How many members are there? We can count them, and it turns out to be 10. So if you are writing the definition for the different functions, this is how we will be saying that. Hey, double is L and double W. If L is greater than or equal to 0, set the length to L, otherwise set it to 0. So we are doing some checks and balances before we blindly set the member variables length and width with the incoming L and W parameters. Here we have the length, we are returning the length, returning the width. What's the area? Length times width. That's the area of a rectangle. And what's the parameter? Double the addition of length and width is the parameter. We are printing the information, the length and the width, and then we have the constructor in which we are just simply calling the set dimension to set the length and width. And we have the default constructor where we are setting the length and width to 0. Now let's just say we are creating a box. A box is, imagine, a three-dimensional entity. So it will have length, width, and height. And it will have a set dimension, which is different from the set dimension in the rectangle type. But this is a derived class because you can see we are using a colon sign, public and rectangle type. We have get height. Why do we need get height? Because the get length and get width are provided in the base class, rectangle type, but it doesn't know anything about get height. So we have to implement it. Why are we implementing the area? Well, the area for a box is different, therefore we have that. Volume, we have that. We are overriding, we are creating a new function by the name print because the print, when we invoke it, we don't want to print just the length and the width. We also want to print the height. Therefore, we are redefining. And then we have a default constructor for this. And we have a constructor which takes three parameters, as you can see here. And it has only one attribute, which is a private attribute called height. This is how we'll be displaying it, and this is the relationship between the base class and the derived class. So far so good. We learned that there is not a whole lot of difference, except that we have to use certain special syntax to define that a class is a derived class. Okay. Now we have, let's just go a couple pages back. We have a function here called area. We have a function here called area. It does length and width, and we are preparing to have another function called area in the box type as well with the same name, same signature. So how do we tell whether to call the area in this class or in this class when we are using these classes? Well, you can do it like this. See, if you are using the base class name colon colon area, then you are saying that, hey, I want to run the area function which is in the base class and not in my child class, in my derived class. Okay, so this is some of the things you will be coming across in our lecture today. Again, same example, that same point that I was talking about. What if you want to run the print function from the base class? Again, similar to the concept we just encountered, we will use the base class name colon colon in the name of the function, which will ensure that the base class print function is executed. What about the definition of the box type print? Hey, we can do rectangle type colon colon print, which will print the length and the width, and then we can console out the height as well. So what is that we are doing? In this derived class print function, we are first utilizing the base class print function, and then we are adding the height, because that's something only the box type will have. How about the dimension? This is very important. When we are having a function called set dimension, we are calling the parent class set dimension to set the length and the width, and then we are setting up the information for the height by doing some small checks and balances, that the height should be greater than or equal to 0, otherwise we explicitly make it 0. And here is the definition for the get height, which is we are just returning the height. How about the area? Now I remember seeing that we have an area function in our base class, and here we are trying to create another function with the same name for area, which is basically we are saying get the length and the width, and then add it to the length and the height, and add it to the width and the height. Now we are directly accessing height because this function is part of box type, and this function is public function, but it can access the private member variable. Therefore, we don't need to use get height and get height. And we are multiplying it by 2 altogether to return the area of the box. What about the volume? We get the area, multiply it with height, and return the volume of the box. Okay. Constructors of derived and base class. This is somewhat different, therefore we are talking about it separately. The derived class can have its own private member variable, such as the height, we just saw in case of box. So a derived class can explicitly include its own constructor to initialize them. What we are trying to do here is, when we are having a derived class can have a constructor, and to create an instance of the derived class. But when you are calling the constructor of the derived class constructor must also call the constructor of the base class. Okay, so here we have the constructor, which is the default constructor. So we are saying box type is the name of the class, and that's the name of the function as well. That's why it makes it a constructor. And what are we doing? We are setting the height to 0, 0. Now, how about calling the default constructor? Because this is the default constructor, then when this constructor is called, it will automatically call the default constructor of its base class. We do not specify any constructor of the base class in writing the definition of the default constructor. So when we are writing this, it will automatically call the default constructor of the base class, and it will set the length and width to 0, because we just saw in few pages ago how it is done. What about the overloaded constructors? Well, here's how it will work. If you are saying this is my constructor which takes 3 parameters, length, width, and height, then how do I call a constructor in my base class? You would, in the signature line of the function itself, you are going to call we'll write a colon symbol, and then we'll write the name of the base class constructor, where we are supplying what is needed, the length and the width, and the height is set according to the simple calculation they are doing. So in this example, when you are creating an instance of the box type class by calling in the constructor taking 3 parameters, it will first and foremost call the rectangle type, its base class constructor, and then it will do whatever logic it's supposed to do. So in this first example, which is rectangle type, if you're setting 5 and 3, the length will be 5 and the width will be 3. If you're calling my box, which is an instance of box type, sending 650, then 6 and 5, the first 2 parameters are the length and the width, which is what we'll set, and the third parameter will be height, which is part of the my box or the subclass. Okay. If you print the myRectangle.print, then it will print the length and the width. If we just end line and then myBox.print, then it will print length, width, and volume or height, excuse me, as follows in this line that you see here. Why? Because that myBox, uh, that line we are writing myBox.print. What is myBox? MyBox is an instance of box type, and box type has a print function which basically changes the definition of the print function from its parent class, where it invokes the parent class print function, but it also displays the height. And therefore, three information will be displayed: the length, the width coming from base class, and height coming from the child class, which is what is explained here. So here another example where we are talking about the same thing, rectangle and box type. So this company is a lawn care, and they specialize in fertilizing and fencing the lawns. For the simplicity's sake, the lawns are assumed that they are in a rectangle shape, and Linda has a gift store in wrapping small boxes, which will basically utilize the box type. So how do we use it? We have rectangle type.h class, the header file, and box type header file along with the other necessary header files. And we are saying yard, which is a rectangle type because that's the assumption being made. And then we have some fence cost per foot, fertilizer cost per square foot, and so on. What we are doing is we are asking for length and width, setting the dimensions, and then displaying the cost. As you can see here, we have the cost being accepted, and then depending on the parameter, we'll calculate the cost. Depending on the area, we'll calculate the fertilizer. Here we have an example of box type where we are saying, hey, you need to gift wrap a box. Sure, we create an instance called a package. We have the height. We are asking for wrapping cost, so we enter the asking for length, width, and height, calling the set dimension on this box type, which is the derived class, setting the length, width, and the height is set in the derived class. The length and width are set in the base class, which is rectangle type. Okay, and then depending on the cost for the wrapping, we calculate we use the area, multiply it with the cost, and divide by 100 to get the value in dollars. So this is the example. Basically in 41 lines you can actually write the whole thing, provided you have the header files created. So hopefully this will give you a good idea on how to really create a base class and a derived class. Very simple, excellent example that you see here. This is just the explanation of the same thing that we discussed. So here we have our header file for the rectangle type, where we have some public member functions and the private member variables. And we have the constructor where we are calling the public function set dimension. Now let's say we have a box type coming from rectangle. Here's a header file. So you can literally copy paste it, save it into a .h file, and you should be able to run it. When we call the box type, we are using the base class constructor and setting the height. We have already studied that. They are just reiterating some of these points, which will help you further reinforce these points. Here's the topic that we learned at the very beginning. Everybody is a person, and there is a class called person type, but we have a part-time employee where we are not only saying it's a person, but we are also going to implement some additional things for pay rate and hours work. We have a constructor which is taking 4 parameters. We have the set name, rate, and hours, which is a function, public function, and the print function. And here's how you will be displaying that. You're saying that this class comes from parent type as its base class, and then here are the information, the private information, and the public functions or public member variables. And here's how you will write it. You are calling the base class print function to print the name, and then you're calling the couple of one additional line to display the wages by utilizing another function called calculate wage, calculate pay, which would calculate the pay of the employee given the rate and the hours. This is just a set function to set the name, which is done in the base class, And then we have the pay rate, which is a public private member variable in the child class, which is part-time. As you can see here in the UML diagram, we are setting the pay rate and hours worked in these two lines right here. Okay, and here's the constructor where we are calling the base class constructor, and then we are setting the rate and hours by doing a very simple logic to make sure these values are more than 0, because nobody gets a rate which is negative, and the hours that you work must be either 0 or positive. How about deconstructor in a class? Well, deconstructor, usually we don't write deconstructors, but whenever we create a class, such as our box type, it will allocate memory for the base class as well. So when a deconstructor is called for a derived class, it automatically invokes the deconstructor of the base class as well. So suppose that class 3 is derived from class 2 and class 2 is derived from class 1, then these classes have deconstructors. When an object of class 3 goes out of scope, first the deconstructor of class 3 will execute, then the deconstructor of class 2, its parent, will execute, and finally the deconstructor of class 1, the grandparent, will execute. That is, the deconstructor execute in the reverse order of the constructor. How do you create the header file of a derived class? How do you tell that the header file in the header file that I come from another base class? So when you are declaring the header file, you need to include your base header file as follows. And then when you are declaring the name of your class, you also use the name of the public, private, or protected. This is how you will do it. Okay. Here, this is what we have learned in the previous pages. The pre-condition, post-condition, and the name of the functions, the signature of the functions, and any private member variables. How about if you need to include multiple header files? What if you need to include, the header file test.a.h includes the test.h again in order to use the identifier 1 and 2. That means this is the base class, this is the child class, and if we are writing a program where we utilize these two header files which are dependent on each other, we might have problems. And to avoid such problems, if we include in a code like this, we'll have compile time error. You will see an error which will result in a compile time. Your code will not compile, saying something is fishy going on. So what you do is, in your test.header, you will write if ndef htest. You will define the htest, you will declare the constants and end it. What's happening here? The first line, hashtag, if ndef htest means if not define htest, then define the htest, do whatever is there in between until you encounter a line called hashtag ndef. This is to make sure that we don't end up declaring these constants again and again, which will cause compilation error. Kindly read through this because this will help you further reinforce the point that are mentioned here. These couple of pages will clarify everything that you might have a confusion about. So here we have another example where we are saying if this is not defined, then define it. Include the integer manipulation.h, and then we have some class we are writing which is derived out of integer manipulation, having factorization, prime factorization, which is nothing but constructor, and a couple of private member variables and one function. and then we have hashtag endif. What this would do is, if we are including integer manipulation along with this header file, it will make sure that the same definition is not executed twice by using the hashtag if end definition. Here, if we include just the prime factorization.h along with iostream, it will not cause any problems because we have used the hashtag if endef clause, which prevents from the compile problem we discussed earlier. What about the stream classes that we are used to using? Perhaps by now we are using the cout for console output, cin for console in. These are derived from iOS class. There is a subclass called iStream, which has another subclass called ifstream for file input and file output. Similarly, ostream to display output on the console, and ofstream to displaying the output or redirecting the output into a text file. These are the way we have used the stream classes in our code that we have written. These are the classes which basically has implementation of different functions from a different point of view. Even though it might be premature for me to say, but this is what we refer as polymorphism, where we can have a function in a base class with a name, and we can have the function with the same name in the derived class, giving entirely different output depending on whether we are calling the function from the base class or derived class. Protected member of a class. So what about the protected in an example that we briefly talked about? Well, when you have a class where you have some information in your base class and you want to use it in the child class, you can use the member access specifier as public, which gives you the information in the base child in the derived class to all the member access variables in your base class. But any other class which derives from your derived class, that means a third level down, it will also have access to all the information in your base class. To prevent that, we can use the protected keyword. The protected keyword basically allows the derived class to access the information from the base class, but nobody else can access that. Okay, there is a keyword we will come across called friend, which will further clarify this point. But protected is an important keyword which you shall remember. If member access specifier is public, that is the inheritance is public, then public members of class A or public members of class B, consider that B is a child class derived from the A class. The protected members of A are protected members of B. They can be directly accessed by member functions and friend functions of B. Now this is, mind you, when we're talking about the public. And the private members of A are hidden in B. They cannot be directly accessed in B. They can be accessed by the member functions or friend functions of B through public or protected members of A. What if we use the member access specifier as protected? The public members of A, which is the base class, they become protected. That means down the hierarchy, they can't be accessed by another class. So we are limiting the scope of the public member variables, public members of A to become protected member, which is what this 2A is talking about. The protected members of A are protected members of B. They can be accessed by the member functions and friend functions of B. The private members of A are hidden in B, just like this point here, just like here as well. So if it is private, then we talked about it earlier. You may kindly go through it. How do we access the protected members in a derived class? So let's talk about it. You have a B class with set data, and print some functions that has the same name but different signatures. They are public, so nothing to worry. And then we have a protected char BCH and a private BX. Okay, and then we have set data, which is what it would do, and then we have a print, which will print it. We have class, which is the constructor name, and then we are setting those two member variables. One of them, BCH, is protected and another one is private. Let's say we create a D class from the B class, and then we have the similar information here. We're talking about how do I get hold of this protected guy right here, up above, which is hiding in my base class from a derived class. So let's get to that. Okay. Now the D class contains a private member variable DA of type int. That's fine. What we are going to do is we are saying, okay, I have a set data function which takes three parameters. In my base class, I have a set data which takes a double, I call it. Now, because the protected members, you can see here, I'm going back just a couple of pages. Protected members of A are protected members of B. They can be accessed by the member functions of B. That means I can directly access the protected member BCH from my subclass by setting it directly, and then DA is a private member in the child class, which I'm setting it anyway. So this is how you can do it. Similarly, if you have to print it, we'll print it and then display the information. Other things are similar to what we have already discussed in the past. Here's another execution example for this same thing that we just learned in a couple of pages ago. You are welcome to create 2 or 3 of these classes and easily run everything to see how things are related, because these are extremely practical points, folks. This is not something that we can just we are learning in theory. This is what developers do when they are writing code for an organization. Okay, so within the class definitions, we can use the class definition. Means when we are writing the implementation of B class and D class, we can use a protected member easily. But when we are using them, when we are creating an instance, like this is a B object and D object, you cannot say D object.bch in your code, because the bch is a protected member variable in the base class. So on an object, you cannot directly say object dot protected member. That is not going to happen. In order to set the value on this protected member variable in your base class, you need to have a function which is public, and then that's what you will call. You will say, I have an object and I want to call a function, and that function basically can access the protected member variable. How about composition? Composition basically is when we are talking about, let's say, a student. Okay, a student has some student information, so we'll be having a class to capture that. But a student also has address, right? Now let's say a student moves from one home to another in the course of finishing his education. So rather than capturing the address information in the student class, we create another class called address, and a student can have one or many addresses. Similarly, a student has financial aid. There could be multiple financial aid or scholarships, right? So we'll create another class. So what we are trying to do here is, rather than combining everything, we try to find out what are the different nouns that we are coming across and create them separately, and then we will compose them, we will combine them together to bring the whole picture. So that is what we are trying to do here with composition. We have in this example a date type. Why? Because individuals has personal information, but individuals also have date of birth. So rather than creating the date of birth as the variables in the person type, we are saying date type is another class, and this will be utilized in the person type to compose everything together. I hope this is making sense, because We are not trying to combine everything, we're trying to keep them as separate as possible so that the complexity of the code is less. This is the implementation example, UML example of the date type. It has all the information pertaining to date, so anybody in the world can use it. If you're working in an organization, you can say, I got the date class created, you want it, use it, send it out to all the developers so that they know there is a company-wide standard date class provided. Okay, and here's the implementation, nothing out of ordinary. We are just setting there is the constructor. It takes the month, day and the year, and it is setting it to the three private member variables. We have a print date, which prints the date, the month, dash the day, dash the year, and then we have the get year, the get date, and get. Within the personal info, which is another class, we will have some public member functions, and we will have the utilization of other two classes, which is person type and date type. This is where they are coming together to create a real example. Okay, so personal info utilizes person type and date type, because rather than capturing all those information in itself, it's using these other classes which are in itself a whole unit and provides information for their individual characteristics. Person type has information about the person name, SSN number. The date has information about calculating date, displaying date, and stuff like that. Okay. Please note this page here, page number 770, is quite important because you will be extending this definition as part of your homework. So keep in mind this date type is important for your homework. And here we are calling when we have our personal info class constructor called, we are calling the constructor of the name type, and we are calling the constructor of the date type. So this is how you are calling the constructors of the two other classes which are used in this composition. Okay, keep in mind these are just some of the syntax which might throw you off, so kindly keep these things in mind. Okay, we are going to finish this chapter with some object-oriented design and programming. So some of the topics that we learn: encapsulation, that means we combine the data and operations on a single data on that data in a single unit, which is the classic example of our class. Inheritance, basically we inherit or create new classes from existing classes. And polymorphism, where we can have a same function in base class and child class with different implementation. So we polymorphize, we create multiple definitions for the same things. These are important topics in object-oriented programming. Object-oriented design basically talks about, you need to think about the coding in terms of class as a fundamental entity. In structured programming, a function is a fundamental entity, and nowadays, with you guys learning programming in this day and age, what my point is, you are learning in the world of object-oriented programming. So I don't want to compare with structured programming at this point. But all I want to say is, when you are doing programming, think about what classes you need, and any real life or close to real life example that you may solve will result into more than one class. So you need to really think consciously about what nouns are present that I can relate to my classes, and what verbs are present that I can relate to my functions within those class. Okay, that's how you will incorporate object-oriented programming. And examples of other object-oriented programming languages out there. How do you identify objects, classes, and operations? Think about all the nouns and verbs. Nouns will give you classes and verbs will give you the actions. After you identify a class, the next step is to determine three pieces of information: operations that an object of that class can perform, operations that can be performed on an object of that class type, and information that an object of that class type must contain. So please go through this few pages, We are at the end of this chapter. We are looking at a comprehensive example about grade report where a college wants your help to generate the report card for a student. And if the student has financial aid paid off, then his or her grades will be displayed. Otherwise, it will display another information. Various things that you have learned in this chapter are incorporated in this comprehensive code exercise at the end of this. Our textbook provides you a copy of this as well, so you can download the copy, or in my opinion, if you're really serious, you can write this code and get your hands dirty, which will get you to learn and practice with writing the code we have come across in this chapter. Okay, it's pretty comprehensive but extremely useful. You have 16 points for quick review, which would help you summarizing what we have learned. The exercise, the code that you need to write for chapter 11 is, let's just go through it. So this is the exercise 2 on page 806. So let's go to page 806 and take a look at it, what we need to do. In this chapter, here we go. Let me make it easy on your eyes. This is what you need to do. In this chapter, the class date type was designed to implement the date in a program, but the member function setDate and the constructors do not check whether the date is valid before storing the date in the member functions. Rewrite the definition of the function setDate and constructor so that the values for month, day, and year are checked before storing the date into the member variables. Add a member function isLeapYear to check whether a year is a leap year. Moreover, write a test program to test your class. Basically, you will need you need to have a class which would use the date type class. You will have your date type class itself, and you will have a date type header file. There will be 3 files you will be submitting for this homework for chapter 11, which is exercise 2. You need to learn how you would write the header file for date type. You will have to write the code for date type, and there is a function called setDate. There is a constructor. In both of these, you will be using the isLeapYear. Basically, if somebody calls the date type constructor, you are going to call the setDate. The setDate will see if the month is greater than equal to 1 and less than equal to 12, then you will set the month. Otherwise, you set the month to 1. Okay. It would look somewhat like this. So here is the implementation for the date type. We are having the setDate, and we are not just blindly setting the year. We're saying if year is more than greater than equal to 1, then we set the year. Otherwise, we default it to 1900. If the month is greater than equal to 1 and less than equal to 12, then we set. Otherwise, we set it to 1. How about the day? We have a switch statement. We're saying, okay, send the month. If the month is 1, 3, 5, 7, 8, 10, and 12, then we are allowed to have 31 days. Therefore, we check for 31 days. The other months have 30 days, and therefore we are checking. Otherwise, we set it to 1. For case 2, which is February month, we are using a function called isLeapYear. And if it is a leap year, then we check the date to be 1 and 20, between 1 and 29. Otherwise, we check it to be between 1 and 28. And the leap year can be complicated, but you can Google it. It's a very, very good thing. Here is the definition of leap year, which is if when you divide the year by 4, the remainder should be 0, or divide it by 100 and then it should not be 0, or if you divide by 400, then it should be 0. If this or these two conditions are met, then it's a leap year, and that's when you are going to check the date for that leap year can have a day 29. and this is what you have to do. Eventually, when you are done with this, basically you will also be writing a code which would run your application, and here is how it will look like. You are just declaring a couple of few instances of your date type, and then you're just printing the date to just make sure your code is working properly. Okay, the header file for your date type will look like this. The header file will resemble like this. They should have code like this, where you are saying if ndef date underscore h, declare it in the next line. Write the header file definition for your date type, and then write hashtag ndef. This is just the header file. You have back-to-back implementation of header file. You have your date type implementation file. Okay, and then in the constructor, you're just simply calling the set date, because you don't want to write the same thing again and again. You're just calling the set date again, and then you have your implementation file where you are running the code to try something, different examples. When I receive your code, I'll be running your code with this test file just to see if it's working fine or not, by trying to set a February date to 30th and see what it does. Okay, I will be posting this video lecture for chapter 11 right here under week 10 and week 11. So hopefully this video will help you prepare for chapter 11, in which we have learned about inheritance and composition, quite a bit about inheritance, and briefly touched upon composition. If you need any further help, my information is on the homepage. Look forward to hearing from you. Have a good day and good luck with chapter 11. Thank you so much.